Okay, looking at problem number 1, it says find the exact value of the 6 trigonometric functions of the angle theta given in the figure. Use the Pythagorean theorem to find the third side of the angle. So as you look at your original equation, your original problem, you're going to notice that there is only 2 of these given. So on this triangle right here, only 2 and 2 square root of 3 are given to you. So to be able to find that side that's missing, so on your review, this right here is not on there yet. So you got to use the Pythagorean theorem to find that. So using your Pythagorean theorem, we're going to go ahead and substitute that in to our Pythagorean theorem to go ahead and find that third side. So using your Pythagorean theorem, here we have our Pythagorean theorem of a squared plus b squared all equals c squared. So as you look at the figure that they gave you on your review, we had 2 square root of 3, and then we also had 2. So we're going to go ahead and substitute this in. So here's my a, and this is my b, and opposite that 90 is what I'm looking for, which is my c. So substituting this in, I've got 2 square root of 3 squared plus, I'm going to substitute in my 2 squared all equals c squared. Now simplifying this down, so here's my 2, I need to square it, so 2 squared is going to be 4. So the square root of 3 squared is going to be 3. So notice that gives me 4 times 3, which is 12. Now here's my 2 squared, which is 4. Now adding those together, I got 12 plus 4, all equals 16, which is equal to c squared. So now to find my c, I take the square root of both sides, and taking the square root of both sides, I get c is equal to 4. So now that I know that c is equal to 4, you'll notice when I scroll up here, I went ahead and filled in my triangle with that 4. So here is my triangle right here. So there's my side 2 squared root of 3, here's 2, and here is 4. So now to actually find the 6 trigonometric functions, I'm going to use that same SOHCAHTOA. So I need to remember that SOHCAHTOA stands for the following. The sine of theta is opposite over hypotenuse. The cos stands for the cosine of theta is adjacent all over the hypotenuse. And your tangent of theta is equal to your opposite over adjacent. So now scrolling back up here to my chart. Here I've got the sine of theta. Well, the sine of theta, working off my angle theta, so here's my opposite, and this is my hypotenuse. So that's going to equal 2/4, which reduces down to 1/2. Now working with my cosine, I know my cosine, according to my acronym, is my adjacent all over my hypotenuse. So here's my adjacent, 2 squared root of 3. Here's my hypotenuse, all over 4. And you'll notice the 2 and the 4 are going to cancel out, and that reduces down to 1 and 2. So that will reduce down to the square root of 3 over 2. Okay, now my tangent. Working for my tangent, I know my tangent is going to be my opposite all over my adjacent. That's the TOA part of it. So substituting that in, I've got 2, and this is all over 2 square root of 3. So notice these cross out, and I'm just left with 1 all over square root of 3. I rationalize my denominator, and I get the square root of 3 over 3. So using SOHCAHTOA, I've got the sine of theta equals 1/2, the cosine of theta equals the square root of 3 over 2, and the tangent of theta equals the square root of 3 over 3. Now, I just have to remember that the reciprocal of the sine is the cosecant. So here's my 2 over 1, so I take its reciprocal and I get, 1/2, and when I take its reciprocal, I get 2 over 1, which is just equal to 2. So here I'm going to take this reciprocal. The reciprocal of the cosine is the secant. So I just go ahead and take its reciprocal. That gives me 2 over the square root of 3. I rationalize by multiplying both top and bottom by the square root of 3, and I get 2 square root of 3 all over 3. Okay, now when I do the tangent, I'm going to use this one because it's a lot easier to take its reciprocal. So the reciprocal of 1 over the square root of 3 is just the square root of 3, and that's going to give me my cotangent. So that is the reciprocal of the tangent. So now here I have all 6 trigonometric functions using SOHCAHTOA. So I get the sine is equal to 1/2, cosine is equal to the square root of 3 over 2, tangent is equal to the square root of 3 over 3. Cosecant, which is the reciprocal of the sine, is going to be 2. Secant, which is the reciprocal of the cosine, is going to be the square root of or sorry, 2 square root of 3 over 3. And then cotangent, which is the reciprocal of the tangent, is the square root of 3. And that would be the answers to their 6 trigonometric functions. So looking at this next one says find the exact value of the function cosine of negative 330. So you're going to notice the very first thing I remind you of is to use your chart. Now you're going to notice that on your chart, negative 330 is not on your chart, and so you're going to have to use a reference angle. So here is the cosine of negative 330. So remember, to be able to find reference angles, you can add and subtract 360, and you can add and subtract 180. So that's what I do. I'm going to add 360. So negative 330 plus 360 gives me 30 degrees. So that means that the cosine of 30 will have the same answer as the cosine of negative 330, except for it could be positive or negative. So all I have to do is go to my chart now, and I'm looking for the cosine of 30. So I go to my chart, so I scroll up here to my chart, and I find 30 degrees. So make sure you know how to write your chart on your test. So the 30 degrees, I come over here, I find its cosine. So the cosine of 30 is equal to the square root of 3 all over 2. So here is my answer, the square root of 3 over 2. But now I have to double check to make sure whether it's positive or negative. So to determine whether it's positive or negative, I need to go ahead and come to this chart right here and determine what quadrant negative 330 degrees is in. So I'm checking to see this. So remember, as you rotate backwards, so from here to here, so that would be negative 90. And over here is negative 180. So I'm rotating the opposite direction. So this would be negative 270. And then this would be negative 360. So I know that negative 330 is between negative 270 and 360, so I know it's in the first quadrant. So since it's in the first quadrant, you're going to notice that I write right here that it is in the first quadrant. So here it's in the first quadrant. And in the first quadrant, my cosine is positive. So that answer is going to be positive square root of 3 all over 2, which matches the answer of D. Okay, on my next problem, it wants me to go ahead and find the exact value of the sine of 3 pi over 4. So remember, you're going to have to go ahead and use your chart again. Using your chart, I need to use the reference angle. So remember, to find the reference angle, you just ignore your numerator. And that's going to be the sine of pi over 4. So we're going to go check that chart that we just made on problem number 2 and see what the answer to the sine of pi over 4 is. So looking at our chart, so I scroll up here to my chart. I find pi over 4. I want to know what its sine is. So it looks like the sine is going to be the square root of 2 over 2. So then I come back to my problem. So using my chart, I've got the square root of 2 over 2. And now I just have to check to see if it's positive or negative. So I just need to figure out where 3 pi over 4 is located at. So there's 2 ways to do that. You can actually take 3 pi over 4 and you can convert it to a fraction to degrees, because you know that pi is equal to 180. So since pi is 180, I can take my equation, I can take 3 times 180 and then divide that by 4. So I'm going to take 3 times 180 divided by 4. So 180 divided by 4 is going to be 45. And 45 times 3 is going to give you that angle of 135. So now that I know that my angle is 135, I can actually just look at my unit circle. And on my unit circle, I know that this is 0, this is 90, this is 180. So I know that that angle is going to be in the second quadrant. Now since it's in the second quadrant, I know that that answer is going to be positive. So I've written right up here, I'm in the second quadrant. So that answer is positive. So your answer to this problem comes out to be the square root of 2 all over 2. Okay, looking at this number 4. So on problem number 4, it just says identify the quadrant in which theta lies. So you're going to notice that it says that I've got, first off, my sine is less than 0, and my cotangent is greater than 0. So since the sine is less than 0, that means that my sine is negative. And cotangent, that means that the cotangent is positive. And remember, since cotangent, its reciprocal is the tangent, that's also just meaning that the tangent is positive. So if I look back up here at my chart that I made, I can look at this chart and figure out, okay, so I know that my sine is negative and my tangent is going to be positive. So since your sine is negative and your tangent is going to be positive, you just find that on your chart. So notice here's the signs are positive in quadrant 1 and 2. 3 and 4, they're both negative. And now the cotangent, which is the reciprocal of the tangent, it says is positive. So I know that I'm in quadrant 3. So back to my problem on number 4. So number 4, it just says it wants to figure out which quadrant it's in. So if the sine is negative and the cotangent tangent is positive, you just use your positive negative chart from number 2, and this answer comes out to be C, which is the third quadrant. Okay, on question number 5, it says in which quadrant is the terminal side of the angle theta? This theta equals negative 15 pi over 8. I find the easiest way to do this is to remember that pi is equal to 180. So since pi is equal to 180, I'm going to substitute 180 into my equation and solve it. And so when I put that in my calculator, I take negative 15 times 180 divided by 8, and I get negative 337.5. So that is one way that you can find it. And so you can also, if you want to, you can just take negative 15/8 and change that to an improper, from an improper fraction to a mixed number. So that's negative 1 7/8. So two ways you can do this. So I'll do this negative 15/8 first. So since that's negative 1 7/8, so here's negative 1 pi and 7/8 of another pi. That puts that in the first quadrant. Now if you're doing the negative 337.5, again, you'll just go ahead and look at your angle. And remember, this is negative 90, 180, 270, 370, negative 337.5 would be right in there. So you're going to notice that that is the first quadrant. So this answer is A. It falls in your first quadrant. On this next problem, on number 6, it says that we have the directions on number 6 says find one positive angle and one negative angle that are coterminal with the given angle. So you just need to remember that coterminal angles have the same terminal side, which means they differ by a full rotation, which is 360 degrees or 2 pi. So just add and subtract 360 or 2 pi from your equation depending upon what they give you. So notice, since I am in radians, I do go ahead and just add 2 pi to my angle, negative 5 pi over 6. And also I'm going to subtract 2 pi. So now remember, when you are adding and subtracting 2 pi, this right here has a denominator equal to 1. So that means I'm going to have to multiply this both top and bottom by 6 to find your common denominator. Because my laws of fraction say to be able to add a fraction together, you need a common denominator. So here I multiply by 6 and I get the 12 pi all over 6. So now my laws of fraction say I add my numerator, keep the same denominator. So negative 5 pi plus 12 pi is going to give you 7 pi, keep the same denominator, which is 6. On this other one, again, remember this has a denominator equal to 1. So I'm going to multiply both top and bottom by 6. So when I do that, I get negative 2 pi times 6 is going to be negative 12 pi, and 1 times 6 is 6. So now that I've done that, following my laws of fractions, I take negative 5 pi minus 12 pi. I get negative 17 pi, keep the same denominator, which is 6. So my two answers that are coterminal angles with negative 5 pi over 6 would be 7 pi over 6 and negative 17 pi over 6. On this next problem, it says I've got 600 degrees, and it says express the angle in radian measure in terms of pi. So remember, the rule is if I want to convert from degrees to radians, my rule says I just multiply by pi over 180. So when I multiply by pi over 180, I get 600 pi over 180. And I just go ahead and simplify this down. If I want to use my calculator, I could. But since this simplifies down to 60/18, because I divide both top and bottom by 10, I get 60 over 18. And then I just divide both top and bottom by 6. So that leaves me with 10 pi all over 3. So notice this part right here, I just divided by 10, which is just crossing off the zeros. Divided by 6, and it reduces all the way down to 10 pi all over 3. On number 8, it says that it wants me to go ahead and graph y equals the 3 secant of x. So on this problem right here, to go ahead and graph this, you just want to remember that the easiest way to do this is to go ahead and graph y equals 3 cosine of x using dots on your equation. So notice that my amplitude is at 3, and notice there is no number in front of x. So since there's no number in front of x, that means my 5 main points still stay the same. So remember, you got pi over 2, pi, 3 pi over 2, and 2 pi. So its period doesn't change. And it looks like I did make a mistake on this one, because here's my dots. So as I go ahead and graph my 3 cosine of x, you're going to notice that in this problem right here. So here's my dots representing my cosine graph. So here's the dot at the amplitude goes up 3, down here, back up again, so on and so forth. And that's what my cosine graph would look like. Now the mistake I did make is actually when I went to, well, first off, we'll put in our asymptote. So every time you see a 0, you put in your asymptote. So notice there's an asymptote here, there's an asymptote here, and it looks like the in focus isn't working too well, getting my dots in there. But when I go actually to draw in my cosine wave, so normally my cosine wave would look like this. So I need to go ahead and flip it for my secant. So remember, when you're graphing the secant, you're going to graph its reciprocal, which is positive 3 cosine of x. And you just literally flip the graphs. And so this is what it's going to look like. I actually made a mistake here. It should be hitting this dot right here. So I actually drew it a little bit up too high. So this is what your graph should actually look like when you flip it. It should be hitting the top of your asymptotes. So that's what your graph will look like. So just some of the reminders that I put down on this. It says, number 1, you're going to graph y equals 3 cosine of x using dots on the quadrantals. Then number 2, put in the asymptotes where cosine equals 0 because 1 over 3 cosine of x is undefined at those points. And then 3, flip the cosine wave, including the amplitude. So keep those in mind as you are doing your problems on your graphing. So let's take a look at this next graph. So on this next graph, it says that y is going to equal the sine of x over 4. So again, notice that you have your main quadrantal points. So let me slide this over just a little bit so we can see our main quadrantal points. So notice that the amplitude, which is right here, which is going to be 1. So that's what it's going to oscillate between. And then notice that this right here is 1/4. So that means that my graph is going 1/4 as fast as a normal sine graph would go. So that means that I need to take my 5 main points. So here's my 5 main points at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to divide each one of those by 1/4. Now the reason why I don't include 0, and a lot of times when I talk about my 5 main points, is because, of course, 0 divided by 1/4 is just going to be 0. So my first main point is at 0. Now my next quadrantal, which is a pi over 2 divided by 1/4, so when you flip and multiply, you're going to end up with 2 pi. And then when you take pi, divide by 1/4, you flip and multiply, you end up with 4 pi. You can go ahead and flip and multiply, cross cancel, you get 6 pi and 8 pi. So those are going to be my main points that I'm going to use for my graph. So notice the one here is 0. I don't ever really consider that one because it always comes out to be 0. But here's my 2 pi, 4 pi, 6 pi, and 8 pi. So those are my main points that are going to be used for my graph. And then you'll notice that I just go ahead and put in the negatives also. So I'll slide this over and slide up a little bit so you can see the negatives. I forgot to write the negative signs in there. So make sure you remember this is negative 2 pi, negative 4 pi, negative 6 pi, and negative 8 pi. So once you have that down, and you've got that on your graph, now we just need to go ahead and graph our sine wave. So remember, your sine wave starts at the origin. So here at the origin I'm starting. And it's going to go up to 1, back to 0, down to negative 1, and back to 0 again. So that's your pattern. And now you just go ahead and draw it in when you're done. And I'll put my negative signs here again, so I will get those negatives in there. So that's what your graph of y equals the sine of x over 4 looks like. On number 10, they give you a drawing here on number 10. It says a photographer points a camera at a window in a nearby building, forming an angle of 43 degrees with the camera platform. If the camera is 54 meters from the building, how high above the platform is the window? Round to 2 decimal places. So they actually show you a drawing of what it would look like. So here's my drawing, my right triangle drawing that is also given to you. And so I just need to remember with my right triangle trigonometry, I need to use SOHCAHTOA. So I know that sine is opposite over hypotenuse. That's what SOH stands for. This next one, the CAH, which is pronounced ka, that stands for cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I just got to identify which one of those it matches. So when I'm working from my 43 degrees, I come on here and that's my opposite, and this would be my adjacent. So since it's opposite over adjacent, it actually matches up with the tangent. So now I just have to set it up using my tangent. So I set it up. Here's my degrees right here. So I write tangent of 43 degrees equals x all over 54. So here's x all over 54. And then I just got to go ahead and solve this. So solving this equation, I'm going to multiply both sides by 54. And so here's my thing that I type in my calculator. I'm going to type in 54 times the tangent of 43. And you can notice that over here on the right-hand side, I just say, just to remind everybody, make sure the calculator is in degree mode. So check your mode on your calculator. Make sure it's in degree mode. Type that in your calculator, and when you type it in your calculator, you're going to get 50.36 is your answer. So it says that how high above the platform is the window? Well, the platform, or high above the platform is the window, it's going to be 50.36, and it looks like we are in meters. Okay, on this next problem, on number 11, it says a 14-foot ladder makes an angle of 56 degrees at the ground as it leans against a wall. How far up the wall does the ladder reach? So you're going to notice on numbers 10 and 11, we're using our right triangle trigonometry. So there's going to be 2 problems on your test involving right triangle trigonometry. The one problem, they'll draw it out for you. That's number 10. The other problem, you kind of have to draw it out yourself and then decide which of the trigonometric function you're going to use to solve it. So I go ahead and draw this out. So you're going to notice here I've made my wall. And the problem says that a 14-foot ladder. So here's my ladder. It's leaning against this wall. And so you're going to notice I labeled it the 14 feet. It says it makes an angle of 56 degrees with the ground. So here's my ground right here. And I make my angle of 56 degrees. So the directions say how far up the wall does the ladder reach. So notice how far up it reaches would be this distance from here to here. So I just go and label that x. So now that I've gone ahead and drawn my figure, I go and decide which of those trigonometric functions it matches. So you just have to remember the saying so, ka, toa. So notice the sine stands for opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the opposite over adjacent. So working from this 56 degrees, there's my opposite side. And then this up here is opposite the 90, so that would be my hypotenuse. So I'm going to use my sine function to solve this problem. So here's my sine of 56 degrees. So here's my opposite, which is x, all over my hypotenuse, which is 14. So now I go ahead and solve this. I'm going to multiply both sides by 14. So you'll notice the 14 comes over here. So I got 14 times the sine of 56 degrees, all equals x. So once again, check to make sure your calculator is in degree mode before you actually type this in. And if you type in this in degree mode, then your calculator should give you the answer of 11.61 feet. So that would be the answer to number 11, would be 11.61 feet. Moving on to the next problem, it says on number 12, it says we want to find the cosine of 100 or negative 120 degrees. That looks like positive 120 degrees. So finding the cosine of 120 degrees. So we're just going to get this off our chart. So remember on number 2 we wrote down our chart. So make sure that you have that chart and that reference angle chart written down on your test. And so to be able to do this, I'm going to find its reference angle. So to find the reference angle, remember I can add and subtract 360. I can add and subtract 180. I can also take 360 plus or minus the angle and 180 plus or minus the angle. This will preserve your coordinate answers. So my first step is to go ahead and take that 180. I'm going to subtract it from 120. And when I do, I get 60. That is my reference angle. That is the angle that will have the same coordinates as 120, except it could be positive or negative. So then what I do is I go ahead and I go back to my chart on problem number 2. So if we scroll back to number 2, I'm looking at the cosine of 60. So remember, make sure you write down this chart somewhere on your test. So here I am with my chart, and I go to 60 degrees. And so here I am at 60. And it wants to know what is the cosine, or what is that x coordinate of that particular place. That is 1/2. So you're going to remember that we are also, that is our reference answer. So we got to check to see, our original problem was the cosine of 120. So notice here is my answer of 1/2. But now I got to check my other chart to see if it's positive or negative. So I'm going to scroll up to this other chart right here and see if that comes out to be positive or negative. So we are looking at 120 degrees. So since we're looking at 120 degrees, so here is 90, here's 180. So 120 is going to be falling somewhere right in here, and I notice the cosine is negative at that particular point. So that means that my answer, if we go ahead and scroll back down to this problem that we're looking at on number 12, you're going to notice that it is a coordinate of 1/2, and that since that is in the second quadrant, that would be a negative 1/2 as your answer. So don't forget on number 12 to check both charts. So again, just a reminder, it says second quadrant is negative. Use the chart from number 2 and your reference angle. So here were all your charts that we wrote down on number 2. So here's our answer, which is negative 1/2. Now in this next problem, on number 13, it says rewrite the indicated function in term of the angle's reference angle. Use the same function. So we have to remember that a reference angle is any angle between 0 and 90. So remember, your reference angles are acute angles, and they're your first quadrant angles, and those angles are between 0 and 90. So it's a first quadrant angle that we're looking for. So again, we can use the two numbers that work to find the reference angles of 180 and 360. So you're going to notice that in this case right here, I'm going to subtract it from 188 minus 180, and that's going to give me this angle of 8 degrees. Now I just got to find out if it's positive or negative. So again, using that chart from number 2, I'll just go ahead and make a rough sketch right here. We know that 188 degrees would be in this quadrant right here, which is in your third quadrant. So since it's in the third quadrant, I just have to remember for my chart from problem number 2 if that is positive or negative. So sine, which is your y-coordinate, is negative in your third quadrant, and that's why this is negative. So that is negative sine of 8 degrees would be the exact same answer, same coordinates as the sine of 188 degrees. So remember, sine is negative in the third quadrant. Find your reference angle. So subtract what from 180, you'll get 8, and then put the negative with it. On number 14, it says that y equals negative 3.5 cosine of x over 3. So all this wants to know is the amplitude in the period. It doesn't want us to graph it. So to solve this problem, I just have to remember that this first number right here is my amplitude number. But remember, that number is always the absolute value. So absolute value means it's always positive. So that means to find this amplitude, I got to take the absolute value of this number right here, which would be negative 3.5. So the absolute value of negative 3.5, since amplitude represents distance, it means that it's going to always be positive. In other words, the absolute value. So that's why it comes out to be 3.5. Now the other question that it wants us to do is it wants us to find the period. So notice on a normal graph, a period is the time it takes for something to repeat itself. And in this case, a normal period is 2 pi. That's the normal period. This graph right here, if I rewrite it, this is actually 1/3. So this is going a third as fast as a normal cosine graph is. So if I take this 2 pi and divide it by 1/3, that's going to be what my period is, or how long it's going to take for this graph to repeat itself. So notice right here, I take 2 pi. So 2 pi divided by whatever that number is in front of x, which in this case was 1/3. So 2 pi divided by 1/3, flip and multiply, and you get the answer of 6 pi. So my amplitude is 3.5. My period is 6 pi. Okay, on this next problem, number 15, it says we have y equals the sine of theta. And it wants us to identify the trigonometric function as even function or an odd function. So the way I remember this is, I just remember the graphs of even and odd functions. So even functions come from x squared graph. And so that looks like this. And so since it is that way, that means that even functions have y-axis symmetry. Now odd functions, in algebra, the most basic odd function would be x cubed, and it comes from this kind of a graph. And notice this has what's called origin symmetry. So even functions have y-axis symmetry, odd functions have origin symmetry. So as I look at this problem right here, it's just a matter of identifying which ones are even and which ones are odd. So I start off with the cosine wave. So if you remember what the basic cosine wave looks like, so it looks like this. So it starts up here and then goes down, and then starts down there and goes up. So you're going to notice that this is symmetrical across the y-axis. So that is why cosine is an even function. And also its reciprocal will also be an even function. So cosine and secant are your even functions. Now if I look at my graph of my sine, so here's the graph of your sine wave. It starts right here at 0, 0. And it looks like this. You're going to notice that it is symmetrical across the origin. So that's why sine is an odd function, because it's symmetrical across the origin. And its reciprocal has the same type of symmetry. So that's why it is also an odd function. Now if you look at your basic tangent graph, your basic tangent graph has an asymptote, and it has another asymptote. And then its graph looks like this. You're going to notice that it is symmetrical across the origin again. So that is why tangent is also an odd function, and its reciprocal would also be an odd function. So you just need to remember that cosine and secant are even functions. Sine, cosecant, tangent, cotangent are all odd functions. So that means that since this is the sine of theta, it is an odd function because it is symmetrical across the origin. And that would be your answer to that problem. It is an odd function. Okay, on this next problem, it says that we have the secant of theta equals 5/4, and it just wants me to find the cosine of theta. Well, if I remember that the cosine of theta is the reciprocal of the secant of theta, that means all I have to do is just take my fraction and flip it. So cosine of theta is its reciprocal, so I flip this fraction, so 5/4 becomes 4/5. On this next problem, on number 17, it says we got the cosecant of 54 degrees, 27 minutes, and 26 seconds. And the directions just say use a calculator to evaluate the function. Be sure the calculator is in the correct angle mode. But before I do that, I have to remember I got to convert this 27 minutes to a decimal. And I also have to convert 26 seconds to a decimal. So the easiest way to do this is just take your calculator and just type into your calculator 54 plus, now remember that minutes means that this is based on the clock. And so that to convert that to a decimal, I have to divide it by 60. And so this means minutes, and this means seconds. So I have to divide that by how many seconds are in an hour, which is 3,600. So when you type that into your calculator, you're going to get this right here, 54.4572. Now the cosecant key is not in your calculator, so you have to use its reciprocal. So using the reciprocal of the cosecant, type in your calculator. So on this problem right here, I'm going to change this to 1 all over the sine of 54.457. The reason why I do this is because the sine is the reciprocal of the cosecant. So now you just use your calculator. So when you take your calculator, you type that in. So if you take your calculator, and let me see if I can slide my calculator out of the way here, and we'll type it in and show you how to get this right answer. So sliding your calculator over just a little bit, I'm going to put it right over here. So I'm going to clear everything out of there. And the first thing I'm going to do is I'm going to check my mode and make sure that it's in degree mode. Now that I've checked my mode, I'm just going to type this in. So I'm going to type in 1, then I'm going to type in divided by the sine, and now I'm going to type in that 54.457. Hit enter, and you'll get an answer of 1.2289. So there's your answer of 1.2289. On that problem there, just remember, use your calculator, make sure you're in the correct mode, and if necessary, use the reciprocal. Because you look on your calculator, there is no cosecant key, so you always have to use the reciprocal key for those problems. Okay, number 18. The problem says that we have, on number 18, it says sketch a right triangle corresponding to the trigonometric function of the acute angle theta. Use the Pythagorean theorem to determine the third side and then find the indicated trigonometric function of theta. So you're going to notice that here's my original problem. It says that cosine of theta is equal to the square root of 2 over 2. So since the cosine of theta equals the square root of 2 over 2, I'm following my acronym. Here's my acronym, CAH. So that means that off of theta, this is going to be my adjacent, which is the square root of 2. And then this is my hypotenuse, which is 2. So now that I've labeled my right triangle, so notice the very first thing I did is I just drew a right triangle, labeled it, I have theta there. And now that I've done that, I'm going to go ahead and use the Pythagorean theorem, a squared plus b squared, to find my opposite side. Because it says it wants me to find my tangent, and my tangent is opposite over adjacent. So first thing I need to do is go ahead and put this into the Pythagorean theorem. So you'll notice that's my first thing that I do. So here's my a value right here, which is the square root of 2. I substituted it into a squared. And here is my b value, which I don't know. And then my c value is 2 squared. So solving this problem, I take the square root of 2 and square it, and I get positive 2. I take b squared and just write it down. That's what I'm looking for, all equals 4. Now I go ahead and subtract 4 from both, I subtract 2 from both sides, and I'm going to get an answer of 2. So I've got b squared equals 2. So So now I take the square root of both sides, and I get b equals the square root of 2. So now that I know that b equals the square root of 2, I come back up here to my triangle, and I go ahead and substitute it in, and just right there, I've got b all equals the square root of 2. Okay, now the directions aid just wants me to find the tangent of theta. So to find your tangent of theta, you know that from your saying, SOHCAHTOA, that tangent is going to be opposite all over adjacent. So since tangent is opposite over adjacent, I just have to come back to my triangle here. And working from theta, so here's theta again, so here's my opposite, and here's my adjacent. So opposite over adjacent, so I write it over here as the square root of 2 over 2. And then I go ahead and simplify that down, and the square root of 2 over 2, the square root of 2 divided by the square root of 2 is going to be equal to 1. And so that will be your answer to your tangent of theta. That is equal to 1. Okay, number 19. It says it wants me to go ahead and express this as a degree. So there's two ways to do this. You can actually use a conversion, or you can just remember that pi equals 180. So I just replace pi with 180, and I get 180 divided by 9 equals 20. Now if you want to, you can use your conversion, which just says if I want to go from radians to degrees, you multiply by 180 over pi, and you'll see you get the exact same answer. All that's actually doing is just crossing it out. So those cross out, you get 180 divided by 9, and that answer is 20. So two ways to do it. If I can, I usually just use the equal thing, that pi equals 180, and I just substitute it in. Okay, number 20. Number 20 says that we have this set of coordinate pairs. It says we've got 5 and negative 12. And it wants me to, it says the point given is on the terminal side of an angle in standard position. Find the cotangent, the secant, and the cosecant of the angle. So the first thing I do is I remember my right triangle trigonometry. So your right triangle trigonometry written in coordinate form. So I remember that the sine of theta is your y-coordinate divided by the radius. Cosine of theta is your x-coordinate divided by the radius. The tangent is your y-coordinate divided by the x-coordinate. And then, of course, here's the reciprocals. So this is just r over y for the cosecant. The secant would be r over x, and the cotangent would be x over y. So in coordinate form, that's what SOHCAHTOA actually comes out to be in coordinate form. So the very first thing you have to do is you have to find this value right here of r. You're going to have to find your radius. So to find your radius, we're going to use the Pythagorean theorem. So remember, your Pythagorean theorem is just x squared plus y squared all equals r squared. So to do my Pythagorean theorem, I'm going to substitute this in. So here's my x, 5. Here's my y, negative 12. I substitute those in. And when I substitute those in, I get 5 squared. And that's going to be equal to 25. Negative 12 squared is 144. I add those together, I get 169. I take the square root of both sides, and I get r is equal to 13. So now that I know that my r is 13, I can go ahead and fill out my chart here. So here I have my x and my y coordinate, 5, negative 12, and my radius is at 13. So if I want to find my cosecant, I just take my radius divided by the y coordinate. If I want to find my secant, I take my radius divided by the x-coordinate. My cotangent would be my x-coordinate all over my y-coordinate. So you can see that's how I fill it in next. So down here, I just remember that cosecant is going to be my y-coordinate, or sorry, my radius all over my y-coordinate. So that's why it comes out to be 13/5, and that is negative right there. And you can put the negative wherever you want to. So the secant, remember, is r over x. So that's going to be 13 all over 5. And your cotangent is x over y, so that is negative 5/12. And that would be your answer for your cosecant of theta, secant of theta, and your cotangent of theta. Okay, number 21. Number 21, it just says, use a calculator to evaluate the sine, cosine, and tangent of the real number, round to 4 decimal places. So just go ahead and put this in your calculator. So to put it in your calculator, make sure that you are in the correct mode. And if I remember right, we changed it already to degree mode, so let's go ahead and check to make sure. It should be in radian mode. That's what it is. So change your calculator radian mode. And once you're done doing that, you can just type it directly in your calculator. So the first one I'm going to type in my calculator is going to just be the sine. And then I've got 8 pi, no, so 8 pi divided by 9. And I just hit enter, and it looks like it comes out to be 0.3420. Next one that it wants us to put into our calculator, it says, wants also the cosine. So cosine, put it in your calculator, 8 pi divided by 9. Hit enter, and you'll get negative 0.9396. And I just rounded that off to 7. And then also put in your calculator this last one. So we got the tangent. So type it into our tangent. We've got 8. And then we have pi divided by 9. And you'll get negative 0.36, and I just round that off to 40. So number 21, it's just using your calculator. So just type those in your calculator, and you'll come up with the correct answer. Just make sure you're in the correct mode. Again, number 22, it says it wants me to graph y equals 2.5 sine of x. And so the very first thing I do is I check to see if my main points along my x-axis changed. So that's a 1, so that means that all my main points stay the same. So notice it's pi over 2, pi, 3 pi over 2, and 2 pi. And I put in my negatives, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And I check the amplitude. So this amplitude is at 2.5. So that means it's going to oscillate between 2.5 and negative 2.5. So now that I've done that, I just put in my pattern for my sine. It starts at 0, 0, goes up 2.5, back to 0, down to negative 2.5. And again, just following that pattern on the negative side. And once you're done, just fill it in, and that would be your graph of y equals 2.5 sine of x. On number 23, it says it wants me to go ahead and sketch the graph of this function, y equals negative 4 tangent of 2x. So the first thing I notice is that tangent, if you remember its graph, this right here, that would be, for my other trig functions, would be my amplitude. But since it isn't, and tangent doesn't have an amplitude, all this means is that this negative means that this is going to be going down, and 4 is just going to make it a little bit steeper as it goes downward. But I do notice that my period has changed. My period is going twice as fast, so my 5 main points need to be divided by 2. So do your 5 main points and divide each one of those main points by 2. So remember, your 5 main points are normally at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so when I go ahead and divide those out, 0 divided by 2 is 0. So I'm showing that first quadrantal. And then pi over 2, I flip and multiply, I get pi over 4. Tangent, dividing by 2, that just stays at pi over 2. 3 pi over 2 divided by 2, I flip and multiply, I get 3 pi over 4. And 2 pi divided by 2 is going to be pi. So these are the main coordinates that are going to be found along your x-axis. So I go ahead and make my graph. So notice on my graph, here's my main points again. So pi over 4, pi over 2, 3 pi over 4, and pi. And I put it in as my negatives. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And then this right here would be your asymptote. So remember, the pattern is it goes from 0 to an asymptote. So 0, asymptote, 0, asymptote, so on and so forth. And once you got that pattern in there, then you just go ahead and draw it in. So 0, asymptote, 0, asymptote. And then you just go ahead and draw in your points. And since this is negative, it is going downward. And that's what your graph of your tangent will look like. Okay, on number 24, it wants me to go ahead. It says on number 24, it says, find the exact value of the function of secant of 405 degrees. So remember, anytime that you read the word exact value, that means it comes off your chart. So to find it on my chart, I'm going to have to find the reference angle. So notice the very first thing I do is I find its reference angle. So I take 405 minus 360 and I get 45. So that is my reference angle. Remember, reference angle is between 0 and 90. And you find the reference angles by adding, subtracting 180 and adding, subtracting 360, or taking 360 plus or minus the angle and 180 plus or minus the angle. So I got to go find the 45 degrees on the chart. But secant isn't on my chart, so I have to go find its reciprocal on the chart. And I notice that the reciprocal of the secant is the cosine. So I'm going to go find the cosine of 45 degrees on that chart. So I go back to my chart from number 2. So going all the way back to number 2 here, let's make our graph a little bit smaller, or things a little bit smaller so we can get back to that chart a little bit faster. So looking at our chart on number 2, we've got to go find that cosine of 45. So the cosine of 45, let's look at my chart right here. I'll go ahead and blow it back up again. So this might be a little bit too big, but we can see it from here. So here is my 45 right here. And its cosine is right there, which is the square root of 2 all over 2. So now back to my problem. I know that the cosine is the square root of 2 over 2. I'm going to go back to problem number 24. And fill that in as 1 all over the square root of 2 over 2, since the secant is the reciprocal of the cosine. So going back to number 24, I'll just blow this up to 150. Well, maybe that might be a little bit too big. We'll go back to 125. Okay, so now notice that here I filled in. So this is the same thing as 1 over the cosine of 45. So 1 over the cosine of 45 is 1 over the square root of 2 over 2. So now I go ahead and flip that over. Take its reciprocal. 1 divided by the square root of 2 over 2 is 2 over the square root of 2. I go ahead and rationalize by multiplying by the square root of 2. So when I do that, I get 2 square root of 2 all over 2. Now the 2's are going to cross out. I'm just left with the square root of 2. Now I need to check to make sure which quadrant 405 degrees is in. So checking that quadrant, you're going to notice that I've written here off to the side 405 degrees is in the first quadrant, so it's positive. But let me show you how you can check that. So you go ahead and just make your coordinate sheet. So you know this is 90, 180, 270, 360, and then another 90, that's going to be 450. So you're going to notice that this right here, this is 360. Full rotation, that comes out to be 450 when I add 90 to that. So that means that I'm falling somewhere here in my first quadrant. So since it's in the first quadrant, I know from my chart that the secant has the exact same values as the cosine. And in the first quadrant, my cosine, which is my x-axis or my x-coordinate, is positive. So that means that my answer is going to be positive. So I leave it as a positive, so that comes out to be the square root of 2, and that matches the answer of C. On number 25, it wants me to find the tangent of the arc cosine of 5/13. So you remember when we did these problems together, we used SOHCAHTOA again. Sine is opposite over hypotenuse, cosine is adjacent all over hypotenuse, tangent is opposite over adjacent. Now you're going to have to use that with a right triangle and the Pythagorean theorem. So the first thing I notice is that cosine, this 5 would be my adjacent, and this 13 would be my hypotenuse. So I'm going to make a right triangle down here. So making my right triangle, I'd label my right triangle. So here's theta. So coming off my theta, here's my adjacent, which was 5, and here is my hypotenuse, which is 13. So notice from our original problem, it said that the arc cosine was 5/13, so you label that. Now you're going to use your Pythagorean theorem to find your opposite side. So putting that into the Pythagorean theorem, I've got, here's my 5. Putting that into my Pythagorean theorem, I get 5 squared. B is what I'm looking for. And then C is 13. So I got 5 squared plus B squared equals 13 squared. So 5 squared is 25. B squared stays the same. 13 squared is 169. So now I'm going to subtract 25 from both sides. So 169 minus 25 gives me 144. And then as I scroll up, I'm going to take the square root of both sides. So I take the square root of 144 and I get my answer of B is equal to 12. So now that I've done that, I can go ahead and label my triangle. So notice now I've labeled my triangle here. My triangle is 5 for my adjacent side, 12 is my opposite side, and 13 is my hypotenuse. So now I go ahead and find the tangent. So the tangent is opposite over adjacent. So I just remember that my opposite side. So my opposite side is 12. And my adjacent side is 5. So labeling that, my answer is 12/5 for the tangent and the arc cosine of that. And I even wrote on here that the answer key on your original review is wrong. And it looks like I still didn't get it changed, so keep in mind as you look at your Chapter 4 test review answer key, it does say 12/13. It is wrong. That should say 12/5.